Different robots have different forms of locomotion. Some have limbs to crawl and walk, but inarguably, the simplest way for a robot to move is by wheels. If we look around us, we will notice that there are many kinds of vehicles, and each one of them uses a different drive system to steer and to control the wheels. The drive system determines its suitability to work in the desired environment, and how well it can carry out a given task. Wheeled robots also incorporate different kinds of driving methods to perform the given task effectively. We will discuss 3 types of driving methods in this lesson. The first one is called a differential drive system. It drives the robot by using 2 independent drive wheels. Drive wheels are the wheels attached to motors, and thus, provide the driving force to move the robot. The rest of the robot is supported by a trailer wheel or caster. If both the wheels spin forward at the same speed, the robot will move forward in a straight line. Likewise, if both the wheels spin backward at the same speed, the robot will reverse in a straight line. However, if both the wheels spin in the same direction at different speeds, the robot will move in that direction, but steer towards the side of the wheel that is spinning at a slower speed. This is the same with both forward and backward movements. Moreover, the robot can rotate about the central point of the wheel's axis, when both wheels spin in opposite directions at the same speed. Although differential drive system enables a robot to move around flexibly, it needs 2 powertrains or 2 motors to deliver torque to 2 independent drive wheels. It is impractical for vehicles on the road to have 2 engines due to the cost and complexity. Thus, actual automobiles use steering drive system where only 1 powertrain is needed. Generally, the steering system shifts the steer wheels of the vehicle to the desired direction, so that the vehicle can move in the desired course. In most cars, the front wheels are used as the steer wheels. These steer wheels will direct the movement of the rest of the car. However, there are also vehicles with rear wheel steering system, such as forklift. This design enables forklifts to have better maneuverability in tight spaces. Different steering drive vehicles distribute power to the wheels differently, based on their automobile layout. The basic layouts are front-wheel drive, rear-wheel drive, and four-wheel drive. The same layout can be applied to robot as well. One shared characteristic of differential and steering drive systems is that these robots cannot move sideways. So, is it possible to make the robots move in directions other than just forward and backward? Yes, of course. Introducing the omnidirectional drive system. For the sake of understanding the term, the prefix omni means all. So basically, saying that a robot has an omnidirectional drive system means that the robot is able to move in all directions. One way to incorporate omnidirectional drive system in a robot is by using omnidirectional wheels, or mechanism wheels as the drive wheels. These are conventional wheels with a series of rollers attached to the circumference. By placing the wheels in correct orientation, the robot can move, or turn in any direction by varying the speed and direction of rotation of each wheel. Another way to achieve omnidirectional driving is by shifting all the wheels of the robot to face the desired direction. Besides moving forwards and backwards like the other drive systems, the robot can now move sideways, diagonally, and even turn on the same spot, by simply changing the direction of the wheels. This method requires more motors, but it can operate using the conventional wheels. The omnidirectional drive system is very interesting to experiment with. It gives your robot the ability to move in all directions. Let's get started straight away, and see what interesting things we can do with this drive system.